Looking back at the last recording we did on 4.2.4 with graphing, and we used this strategy where we plotted all the intercepts and then found the positive and negative intervals and then sketched it from the intercepts and the positive and negative intervals. I want to make a few other points. First of all, what about the situation when, what if there are no x-intercepts? There are no x-intercepts. Then all you have is a y-intercept, and that's really not very helpful. Even if I know it's positive over here and negative over here, I guess it kind of looks like that. But what if it, I don't know. It'd be nice to have a couple more plot points. So what if there are no x-intercepts? Then find at least one or two other points, or so I'll just say a few other points on each side of the y-axis. So at least you know if it's going like this or if it's really wide. Give you some idea of what's going on. So that's one thing I want to talk about. The other thing is we can actually use the multiplicity of the zero to see if it's going to be positive or negative by thinking about this. So in general, zeros with even multiplicity, so x squared, x to the fourth, x to the sixth, eighth, tenth, if it's even, then if you think about your parabola, when you have your zero in that even graph, your graph touches the x-axis and then bounces back up. It doesn't cross. So in general, all the even functions, if you have an even root, then you don't change signs and you end up just touching the x-axis and turning your back around. So you can think about, with even, you can think about that parabola shape that bounces back up. It touches the x-axis and then turns around. All right, and then what about when it's odd? So you can think about your x cubed graph. With our x cubed graph, at that zero, it actually crosses. So it changes sign. So look at the example we did on the last recording. Our zero that had of 2 had a multiplicity of 3. So that means at our 0 of 2, we should be changing sign or crossing the x-axis. So here's our 0 of 2, and you can see we went from negative to positive. We crossed the x-axis. Same with at x equals -1. Our corresponding 0 there is x equals 1. That's this one right here. Whoops. So, no, it's not. I'm sorry. That's -1. This one right here. So we cross the x-axis because that 0 has a multiplicity of 1, which is odd. Our even multiplicity, that's this one right here, where x plus 1 was squared. That corresponds to the 0 of x equal to -1, which is this one. And there we just touch the axis and bounce back up. So you can think about the shapes of the square and the cubed functions to think about odd and even. Even zeros that have multiplicity of an even number touch the axis and bounce back up. And if it has an odd multiplicity, then it crosses the axis. All right, and there's one more thing I wanted to point out. So we talked about if you don't have any x-intercepts, then you should find a couple more points on the graph. That was 1. 2 was you can actually find what happens at each of these zeros by looking at the even or odd multiplicity of the 0 to see if it crosses or touches the x-axis. And the third thing I want to talk to you about is the end behavior. So I'll try to make this a little bigger. So you can think again about your even, the end behavior of an even function is the same as a parabola, or x squared. So if a is greater than 0, then your end behavior has both those as positive. So that corresponds to these intervals, these end intervals over here. this plus, it's getting kind of messy. Let's see if I can get a bold color. So this plus over here and this plus over here are because this function has a degree of 6, that's even, and the a value, that the leading coefficient, there's a positive in front, so that means that it's even and increasing. So it has that same end behavior as a parabola. So you can get the end behavior from this idea. And then if it's even and an a is there's a negative in front, if I had a negative here, then these would be both negative. I don't have a negative there, so I'm going to get rid of that. But think of your upside down parabola when a is less than 0 and the function is even. When the function is odd, like x cubed, and a is positive, I'm liking positive first. When a is positive, then we have this shape. So we have our end behavior like that. So that's going to be true for all of our odd functions. With a greater than 0, we have that same end behavior. And with all our odd functions that have a less than 0, we have this end behavior where like that. There. All right. Yeah, so you can see how this thing right here, when I found those intervals by using test points, I also could have thought about the multiplicity of each 0 to see what happens between the zeros and the end behavior.